So welcome to week 4. It's not, oops, one moment. I have to stop my son from playing the trombone. I'm recording. So announcement-y stuff. One, if you go to the main website, then weeks 4 and 5 are both ready. I had a link wrong in week 4, but now it is right. Everything is good. Week 4, we normally would have a quiz, but since we really only have one class day and I just gave you a test, I still don't think we need a normal kind of quiz. We'll do that next week. So for this week, the short answer for B, for homework B, is kind of long. So it's that stuff. So do that sometime, and that will be counted as a quiz. Since it's more work, you will get more recognition as a quiz than just the short answer and the homework. You're welcome to work on it with other people, and I'm going to talk about that a little bit later. Okay, this week's discussion forum is different. So normally you just do one of your own things and then reply twice, but here we are doing surveys. So we're supposed to have 6 surveys and we don't quite yet. People jumped in 1, 2, 3, 4. So 2 people can now ignore me and make the last 2 surveys because they want to do that. But other than that, reply to the surveys. Then you have 2 more things to do. Pick a survey that has at least 10 replies and make a table about it. And then use your table to make one of either a bar, a pie chart, or a Pareto, and you'll know more about those by the end of class. So don't just reply to 2 people, but you have to make something. And because you need to put your chart up, then there's a link right here about tips on including images in the Moodle forum, which is not obvious how to do it. So click on that and you will get taken to the study skills thing with how to do images in Moodle forum. Note that you won't always have pictures look like other people's pictures, because if you make a chart as soon as there are 10 replies, and then 10 more people reply to that survey, there will be more information in that survey, and someone that goes after you will have a different data set. So don't compare each other's pictures, just do your work. And at the end of this week, I say, keep looking over your midterm. The answer key I again link to if you need it. Whoops. So don't let that get rusty. And I think that's all. There's no reference list for this week, just the optional videos and achievements.
Question.
Sure.
So there's achievements for when we started the midterm that says like if you get 70% or not on it, or 80% or not on it. How do we know if we got those achievements if we did it the way we did it on Monday?
Since you should have graded your own midterm, you have to tell me.
Okay.
I only send me a problem or a few problems to brag about.
Well, that's what I wasn't sure of, because you wanted to see a problem. I didn't know if you were just going to base it off of like how we did the steps for that problem or not. That's all my only question.
Yeah, no, almost everyone has sent me something, their bragging rights from what we did Monday. There actually wasn't any achievement for that. I have marked off who's done it, but maybe we'll have to invent a new achievement because you all did that. Okay, so lunch. So we've done that one, we've done that one, we've done that. Now that you've used Discord a tiny bit, some of you, it has very low bandwidth compared to Zoom. So every culture and religion knows that you can build community by eating together, right? Lots of traditions about that all over the world. So I'm wondering if people want to not do studying together, but just pick one day and not watch each other in Zoom, because who wants to watch people eating on camera, but just sort of hang out sometime. So if you like that, say something in chat to everybody or something like that. Next announcement, comparing test photos. I'm going to share a different part of my screen. So a bunch of people have made Google Drive things, and I wanted to show why. So here's a few examples of things that didn't work well. Most of the time, when people send me pictures of their work on email, it's okay. So these are purposefully highlighted images that aren't okay. So if you just send attachments on a plain text format message, that usually works, and so on. But I want to show you how compare and contrast, because you don't get to see my point of view otherwise. So somebody took a picture that's just really hard to write. Even if I open this in a new tab, then I make it bigger, and that's just very blurry. So I'm not sure what they were doing with their camera. That rarely happens, but there was one. Another one is somebody will often send me things like this, which makes it hard to grade. Sideways doesn't work well. Then this is fine, nothing wrong there. And this one, whoops, did I close two? One moment, let me stop my share just in case something funny happens. I thought I had more examples. Come on, load. I thought I had a third example of it didn't work well, but let me show you the ones that do. So somebody shared a drive and they just have images in it. And when I open them, I can go left and right, and everything is resized to fit my window automatically. So that's just nicer. And then this one, somebody has PDFs. I'm not sure how you get PDFs. I know how I get PDFs. I don't know how you are making them, but I can scroll down to see all these pages, and I can go sideways to change from one thing in the drive to another. Right? I'm switching from this one to that one just by going sideways. So that's a lot more convenient for me than for you. But not everyone has to be efficient. If you are somebody that the only thing you can figure out how to do is send me giant sideways photos of your work, you can be the one who does that. But the more people who save my time, the more I am happy and can do other things for you.
So just a note on that, I have a printer scanner, a relatively cheap Canon printer scanner, and one of the options instead of print is just save as PDF.
Oh, okay.
So I just scan it and then save it as PDF on the little thing, and it just automatically does it.
I'm hoping to get a
I
printer.
do it the same way.
Sorry.
Oh, go ahead.
Oh, thank you. Sorry about that. I'm hoping to get a hold of a printer, but in the meantime, I was struggling with the Google Drive. Would you let us know if our emailed pictures didn't work for you? Would you have told us?
Yes,
Or...
so far I would have told you. Everything is good.
Okay, awesome. Thank you.
Okay, I'm going to share my announcements again. We're going to do an arts and craftsy thing. So a reminder, just like I sent out the email, if you need to scurry and get paper and pencils, maybe even crayons or colored pencils, scissors and a tape, maybe a ruler, that could be good for later. And I am right now going to take this Jamboard and share it with everyone, because we had figured out after a couple classes ago that not everyone could get here and edit it. So I'm going to go share and stop watching this and send. And then what was the other one? My folder. So I'm going to go to my drive. I have a folder with all the Math 105 stuff. And I'm going to share that with all of you. Okay, that is done. So you should have just gotten 2 emails, which you don't have to check now, but they are just saying you can now access this and be a vandal and destroy all my hard work. Please don't. And you can see anything I've archived in my Math 105 folder. Okay, that's our announcements. I'm going to stop the recording. So we wanted to talk about the quiz. So part of our new chapter about data is presenting data, not just making tables and charts and all the mathy parts. So at the end of the homework 4B, you have a whole bunch of data just barfed at you, right? Please pardon me as I barf a bunch of information at you. So your task is to try and take all of this and present it somehow. Maybe this means make one nice page like a flyer. Maybe this means put something in PowerPoint. Maybe this means recording a little YouTube thing for 3 minutes. Maybe it means a diorama, who knows, be creative. But the idea is to work on the persuasive part of presenting data, not just the, can I move the numbers around correctly? And I purposefully put a bunch of information that kind of goes all over the place, like a 3-year-old who just dropped his plate of spaghetti on the floor. There's stuff about the carbon footprints, there's stuff about investors, there's stuff about being responsible as an individual, there's stuff about being responsible as a country. So don't hyper-focus. Don't just pick one part of this data and present that somehow. Your task is to try and somehow present all of this. Although like any presentation, it will help to have a target audience. So if you are visiting the Rotary Club and trying to convince a bunch of elderly investors that they should be environmentally responsible, that's different than if you're trying to visit a 6th grade classroom and talk about how industry affects pollution. So go ahead and make a scenario. Give yourself a very definite target audience, because it will be hard to be persuasive if you don't know how you're arguing. Someone in chat asked, do we send those in email? If it's a purely visual thing, then sure. If you draw something on paper or make something in a Word document or whatever, then you can just email it to me. If it's something you want to save and share next time we have class together, that works too. And if it is something that is not only visual, if it's you actually doing some sort of active presentation, then you can do it in class, or you can just arrange to meet with me in Zoom if you don't want to be on stage in front of all your classmates. So whatever works for you, I'm not too picky. Questions about that quiz other than I want to learn about data because it's class time? No. Okay. That we looked at. We don't need more. Kind of as a second announcement thing, we didn't quite finish talking about investments during the week we were supposed to do that. We needed more review for the midterm instead, which is great. But I wanted to just do a little bit more because it helps some people in real life. And so the too quick, but at least these words are somewhere where you know you can look them up. What are the 4 different kinds of accounts that people who save money put them in? And the 4 most common are here. The UTMA I put in yellow because it's a lot less common, but it's still a good one to know about. And so here we go.
You're not showing your screen, David.
I'm not sharing my screen. Oh, bad teacher. There we go. Okay, here we go. So this was the announcement page. Now I'm on page 2. So 3 common and a 4th, not quite as common, but good to know about. So who knows the difference between a traditional IRA and a Roth IRA?
A traditional IRA is an investment account that you would make contributions to that are pre-tax.
Mm-hmm.
And a Roth IRA is an investment account that you make contributions to post-tax. And so if you want to avoid paying taxes in the future, a Roth IRA is a good idea.
Correct.
Oregon actually mandated an IRA that employers provide an IRA account. It's called the Oregon Saves, and that is a Roth IRA. So if any of you are employees, then you very likely have access to a Roth IRA through Oregon Saves.
Yes, if you go to the Investment Week's resource references, then there's a types of IRA accounts, which is right here. And it does talk about the SEP and the employer ones and things like that as well. But the basic idea is if you are thinking that at this point in your life, your taxes are high, then you want a traditional IRA. People in their 40s and their 50s whose careers are established, then I'm going to put money in before I calculate my taxes because taxes are high right now. And later when I retire and I take my money out, then I do pay taxes on it. But my tax bracket will be lower in the future when I'm not working. For most people in LCC, most students in LCC, that's wrong. This is the low income stage of your life. You're a college student, your career has not taken off yet. So you would rather pay taxes now on your investments when you're 65. 65, you probably will have a higher tax rate than in your 20s. So the Roth IRA is sort of the young person's IRA. We're going to tax what you put in, but not what you take out. Okay, this college 529 plan, you have to pick a kid. There's only one that I know of in Oregon, the Oregon College Savings Plan. Again, it's in your reference links. And it is a plan where you put money in and you have to spend it on education on that kid. And the A kid is in quotes because you can switch which kid it points to. If you have several children, then your oldest child you'll point it to first, pay for their education, then redirect it to go at your middle kid, pay for their education, redirect it to the younger kid, go to their education, and so on. Depending on what state you live in, the 529 plans, you might not get your money back if they don't spend it all on education. So you don't want to put too much in them. But that's a very tax advantaged way to pay for your kids' colleges. And relatives can contribute to the 529 plan also. If you have older relatives that want to spoil your kids, then they can put a certain amount of money in each year and it helps them with their taxes. So more details are easy to find online, but not really my job as a math teacher. Then the last one is UTMA. It stands for the Uniform Trust for Minors Act. It's actually out of order, but I'm going to say it that way or you'll get confused. And these are gifts to kids. So you may have heard that there is a estate tax. When an old person dies, then all of their money gets taxed before inheritance happens. So a UTM is how grandparents traditionally give money to grandkids or kids as they're getting old, so that their savings is smaller, and when they finally die, they're not of their estate.
Wait,
The
did you just say there's a death tax?
There's a estate tax, and it might only kick in if you have more than $1 million, something like that. I forget all the rules because
I thought estate tax has to do with property, because the way you're describing it, you're describing a death tax, that when these old people die, they're going to tax all their wealth. So they give it to their grandkids or family members and disperse it out throughout a will so they don't get taxed on their wealth.
Estate doesn't just mean property. It means all your net worth. So the
I've never
UTMA,
heard.
yeah.
Is that
The
just an
UTMA
Oregon thing?
What?
Is that just an Oregon thing or is that a country thing? I've never heard of that before.
It's a federal thing. The UTMA, the parents have control of it till the kids turn 18, and there's strict rules about what you can use it for. It's good for education. It's good for some other things. I'm not going to pretend to be a tax specialist, but you can't just get your grandparents put money for your kids in a UTMA and get your kids a new computer or something like that necessarily. So be careful that it limits how you spend. So these two have very fixed ways you can use the money. This one is just I'm retiring, and when I retire, then I can use it how I want. They all have rules about how you get money out of them. And all of this is about taxes. So partly I'm just giving you this one slide because some of you might have older relatives and this is good to talk about. Partly I am giving this to you now because not this week, but next week, your video will be about a video, your discussion will be about a video someone made about how to save with buying cars. It's a silly video. It's again about presenting the data, not whether or not his investment advice is good. We're learning about salesmanship. And one clue that we shouldn't trust everything this person says is he never mentions taxes. Anyone that wants to talk about investing seriously has to talk about taxes because that's a huge part of using your money wisely. So ta-da, that's all of investing. I'll turn off the recording, Zoom recording. Our new thing is we're going to talk about describing data. So we are in categorical data. We're looking at data that we can make categories about it and maybe make some charts. And I'm going to start by just talking about types of measures we'll make. So I'm going to go over here to the personal finance and typicality. We want to say things like which of these items in a sample is typical. So we need to talk about what the word typical means. Maybe you've seen pattern blocks. Did anyone play with these wood or plastic pattern blocks when they were in school? So if not, just know that they come in different colors. And these green triangles are sort of the typical, not typical, the fundamental one. If I had green triangles, the one on top of each other, then I could make a diamond. I could, here, let me just put this on the Jamboard. Right, so if I had a green here and here, two of them makes a blue. If I had a green there, there, and there, three of them makes a red, and all six greens would make a yellow, if I could actually draw well. As to weigh one, then this smallest one that makes up the others is 1.5 grams. So your first question is, what's the typical weight of a block in this group pictured on the screen? If you have an answer, then stick it in chat. Don't shout it out too early. In chat, people are saying 3 grams. Let's talk about why. And there's no perfectly right answer because typical as an English word is slightly vague. One thing to think about is what happens most often. Maybe you said 3 because the blue one appears most often. So that's what we'll say is typical. Is 2 times 1.5 is 3 grams. Other people will kind of look the other direction and say most representative. It's not that the blue happens the most, it's that there just aren't enough of the greens or reds for them to really be present. They don't show up enough to be kind of in the big picture. So we'll pick blue, but kind of for the other reason. And then some people do something they've been taught earlier. They try and make a mathematical average. They would sum up all these things. There is 2 greens at 1.5 each, 6 blues at 3 each, 1 red at 4.5 each, and they get 25.5. Then they divide by how many? Divide by 9, and they get 2.8, which is pretty close to that same 3. Let's try it again. Let's add 2 big blocks. Now what's the typical weight of a block in the group? Again, there's not quite a right answer. Okay, let's go back to these 3 things. Are there people that said it's the weight of the blue block because that's what there's the most of? Are there people that said, I'll also pick the blue block, but that's just because there's no more than 2 of the others? They discount themselves. There's not enough to be part of the big picture. Or are there people that didn't want to actually do it, but your inclination would be to find out the total of all the weights and then divide by how many blocks and get an average that way? So okay, the point of that, there's a famous quotation. There are 3 kinds of lies: lies, damn lies, and statistics. And people that use that quotation will often use it to imply that statistics can be purposefully misleading. And we've certainly seen that with all of the things that happen in any election year, that statistics get used by both sides to try and argue that they are correct. And they're saying opposite things. But this discussion of typicality is showing us that just the language can be misleading. We don't actually have to be trying to mislead people. Just this confusion about, does typical mean what's most often, or most representative, or some sort of calculated average? That there is some vagueness built in when we're talking about things. So one theme of this chapter is salesmanship, when you can trust numbers, when you can't, how to take the data and be convincing with it. The more you are aware of the ways that things can be misleading, then the more you can catch when people are trying to mislead you. Questions so far about any of that? Do blue and yellow, were they equal, by the way? Since each of these was 3, then yes, there's just as much weight for blue and yellow. Okay, the first word we want is the mean. And ever since elementary school, you've been taught to find the average by adding up all the numbers and divide by how many. So officially, that's called the mean. Mathematicians have a bad habit of taking a common English word and giving it a very specialized definition, like a set or a group or a mean. So this is another example like that. If people say what kind of average they're talking about, it should be safe to assume they're talking about the mean. If they're using the median or the mode, we'll get to those later, then they're misleading you. The mean is the most commonly used ones because in most everyday situations, it does what we want an average to do. We want to avoid the ambiguity and have a number that is similar to all three of these, most often, most representative, and where it balances on a scale. And the mean often does that. So I'm going to take this and stick it on the Jamboard. And here is a challenge for you. I'm just going to clear that one. In a certain preschool classroom, the students have the following weights: 34, 36, another 36, a third 36, two 37s, a 38, two 39s, two 40s, and a 41. So what is the average weight? And we're not saying what kind of average. So this should be the mean. Add them up and divide by how many of all the students in the room. If you get an answer, either share it out loud or type it in chat. Someone has an answer. So if you add them all up, then Robert got it right, I think. It's 453.
No, second. It's over.
Then divide by how many? At 37.75 pounds. If you wanted to round it, that would be great too. Doesn't really matter. So far so good. Questions about that one? No questions. Okay, people are quiet today. Moving on. So the answer to the previous problem feels right. 38, if I was to mark where it is, 37.75. It looks like it's in the middle of all of this. Like if this was a teeter-totter, that's where the teeter-totter would balance. And that's true. So here's another one. This one is drawn to look like a balance. Oops, make it bigger. So somebody is claiming that 5 is the mean in this picture. Is that true? I see some yeses. It's 2. There's 2 2s a 6, and a 10. So that's 20. Divide by how many? And yeah, 5 is our answer. Okay, so that's the mean. Add them up, divide by how many. It's sort of where they would balance on a scale. It's one way to find what's in the middle. And often it's the things that's the most often thing or the most representative thing in a group. It's not always a group member. There isn't actually anything that weighs 5. But the type of digest is called a histogram. So that's our new dragon. It's a bar chart in which each bar counts a different category of things. So I'm going to open this one. Bigger. So here's midterm scores from one of my Math 20 classes a long time ago. One student earned a 48 way at the bottom. The rest of the blues were people 60s. One student earned a 71, one earned a 73, one earned a 76. If you look on the up and down axis, the number of students goes up to 2 for some of the yellows, and then the most common peaks were at 3 students. Everyone has seen histograms before? If you ask some questions, let me know. Okay. So, Oops, I see that got bigger. That's okay. Notice that each student had his or her own piece of bar somewhere. So if I put this on my Jamboard, get bigger, then this is a student, right? Maybe it was Bill. This is a student. Maybe this is Anne, right? Whatever it's happening. This one here is a student. Maybe this is Walt. We could count how many students are in the class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's not always true for charts, right? If I have a chart of what temperature it is from day to day, it might look similar. There might be like the temperature is going here and then it goes up and then it goes down, but it's not true that everything underneath the temperature for a certain day is a collection of points, is a collection of people, is a collection of test scores, whatever those things are. But histograms are counting things one by one. This histogram was color coded. It tried to make it obvious who was in the A group, the B group, the C group, or the D group. But that's not always true. Histograms are designed. The histogram that we looked at first, each of these categories at the bottom was 1.7% big. These are called bins, so I'm going to label that. So each of these is one bin. And you can see why they're called bins. It's sort of like we are playing some sort of beanbag game and we're throwing everything into the right bin that it fits in, right? Which score goes in which spot. If we used a wider size bin, now this is exactly the same data set, but we're going by 5%. So we start at 48 and add 5 and get to 53. We start at 53 and add 5 and get to 58, and so on. Now, if I was trying to color code it by A's and B's and C's and D's, different students would get different grades. The people that were at 58 look like they belong with sort of a third group in this one, whereas here the 58s, not 58, 58 to 62, that was this student here in the blues. They were getting a low D. So how you make your bins, what size goals you're tossing your bean bags at changes the shape of the histogram, often dramatically. And if you don't know this and you make a histogram, you are just sort of leaving it up to your decision what it's going to look like, not knowing what's happening. And there are people that know about this, and they will make histograms with different size bins, maybe 2%, maybe 5%, until the shape of the data looks like what they want to persuade you of something. So histograms are slightly untrustworthy. Oops, okay. So pay attention to the histogram bins. That's one thing. Then the last jargon we have is standard deviation. So here are 4 different histograms. They're showing test scores for a history class. And something weird is happening here. So somebody put into your own words, what's so dramatically different about these 4 tests, or these 4 history classes taking the same test, or whatever this imaginary thing was?
In B, you can definitely see it go, have a decrease and then have an increase.
Yeah, it goes down and then up. This was a really weird test in B. It was pretty easy to ace it, and it was also pretty easy to just completely bomb it. I wouldn't want to take a test like that. That seems really weird.
I feel like D is pretty like predictable. You see kind of a pattern there. Interesting.
It kind of wiggles around.
Yeah.
Yeah. D, it's hard to say what would be most representative. We could count which one is most common. It's this one that goes all the way up to 4 students, but it's not like that's really different than these that have 3 students. So D is sort of all scores were more or less equally typical. Which test would you rather take?
Definitely D.
I was thinking C.
C is sort of like an SAT test. This test has been designed so that most students are average, and it's pretty hard to do better or worse than average. How about test A, which we haven't mentioned yet? What makes that test interesting?
It kind of has like a similar rise and fall.
Mm-hmm. If C is like the SAT, most people do average and only a few do better or worse, then A has 2 groups like that. There's sort of the group that knows what they're doing, and that group has a strong average with a few people doing better and a few people doing worse. And then here's the group that's lost, and they sort of have an average with a few people doing better and a few people doing worse.
A makes me nervous because of that big gap in the middle.
Right. Almost.
What happened?
Yeah, what happened here? How come no one actually scored half? So the mathematicians want words to talk about this. And so the word they use is the standard deviation. The word deviation just means once you get your mean, once you add them up and divide by how many, how far are you from the mean? And so standard, they don't want to say the mean of means. That's just too much meaning. So they standard deviation means what's the standard amount you are away from the middle. So this one has a low standard deviation. Meaning that most of the people that took this test were close to the middle line, right? Whatever the mean is, they were pretty close to that. B is the opposite. This is the highest of all the standard deviations. So if we were to find the mean, we would get the same mean, add them up and divide by how many is still where things would balance if it was a teeter-totter. But how much do they deviate from the mean? How much do they go away? A whole lot. Almost none of them are near the mean. They're way off on the edges. Sorry about my kid's package noise. Okay, which one is not the lowest standard deviation, but second lowest? I can draw lines again. They have the same mean. Does A or D have things in general closer to the middle, closer to their mean?
It looks like D has a closer mean than
Yeah,
B.
if you look at
Yeah.
the extremes, then there's 4 of them that are way too low in both.
Mhm.
There's 4 of them that's way high in both. And as far as what's going on in the center, D has more stuff close to the center.
Mhm.
So this would be the second lowest of the standard deviations.
Yeah, the D graph is just far more inclusive.
This one is the second to highest. Things are starting to flee from the middle in the A graph. They haven't fled to the edges quite as much as B, but they're getting there, right? They're running away. So if you were in Math 25, this is all we would do. You are actually going to, later on in this class, start calculating standard deviations, which is annoying. But for now, you don't have to. Just know that what it means is how much things are avoiding the average value when you look at the data set. A high standard deviation means things are avoiding the average. They're deviating away from the average. If you were doing some research, what would you want your research results to have?
Wouldn't it depend on what you were researching?
Usually not.
Well, but if you were trying to make a positive point, well, yeah, maybe not. If you're trying to, yeah, I got nothing.
You'd want lowest standard deviation.
Right, you want it to be as low as possible. If you're doing a very simple experiment, what are the weights? Here's an interesting one. People have taken professional chefs and said, measure a cup of flour. And even the professional chefs don't always measure a cup of flour precisely, right? So they weigh with a very fine scale how much flour professional chefs make when they scoop this 20 times. You want that to have a low standard deviation. You want almost everything to be about exactly the same, right in the middle. Or something complicated, right? Which policy is best to keep the spread of a vaccine low? Whatever you're measuring, you want it to be predictably effective. If something has a high standard deviation, that means your chef is tossing flour all over the kitchen, or whatever your recommendations for controlling the pandemic are, work one day but not the next. You get no useful information out of that. So patterns happen when things are consistent, when there's a low deviation from example to example. Okay. There are websites that show you standard deviations. So here's one, right? I give it to you. I can just take a bunch of numbers, copy and paste, stick them in here, and say, there we go, 27.68, blah, blah. And here's the formula you'll worry about later. So as I mentioned in one of my emails Monday, everything you do in this class is both fake and real. No one will ever say, sit down on the job with the calculator, find the standard deviation of all of these numbers. But they might ask you to do something that's similarly complicated. So you're jumping through the hoop to prove your math skill is that good. And you will see standard deviation all the time, even if you don't recognize it unless you look carefully. But all sorts of reports on science and politics and policy have standard deviations in the fine print. So it's you learning the background of what's really happening, even if you don't have to do it, and showing you're qualified to do things equivalently tricky. Okay. Now our preschoolers are messing us up. Remember this one with the preschoolers from earlier. Whoops, no. There. So they say, this isn't fair. Our classroom has more than just us. We love our stuffed animals too. So we're going to take our histogram and go way over here. And there's a 1 pound and a 2 pounds. And we're going to make a bar that's 2 high and a bar that's 1 high for our 3 stuffed animals that we love so much. What happens if you try and take the mean now? You're going to add everything up. It was 453. So we'll take the 453. Oops. Old sum, we're going to add the 4 pounds for the stuffed animals and get the 457 pounds. There were 12 preschoolers. Now we're counting stuffed animals person 13, 14, and 15. And whatever that is, 457 divided by 50. So it's about 30.5 pounds. I didn't draw this to scale, but you can maybe imagine that if I had a balance point at 30.5 pounds, it would balance there because this stuff is really way off to the left of the screen. But it's also true that 30.5 pounds doesn't look like anybody in the room. The preschoolers all weigh more than that. The stuffed animals weigh a lot less than that. We've lost sight of how this number is supposed to be typical, what's happening most often or most representative. So the mean is broken. Someone tell me in your own words, why is the mean broken?
We added a couple weights that were much, much lower than the average weight.
That's a good way to say it. Anyone else have a different way to explain it? Then I'll say what is typical isn't really a fair question anymore. Right? The stuffed animals and the preschoolers are two different groups. To try and say a single thing of what's typical in this room isn't realistic because there's two different things happening in the room. So we need a different kind of average for this situation. So this is called the median, and we sort the list and pick the one in the middle. That's big, not so big. So let's go back up a little bit, grab the preschoolers' weights. Pardon me while I make that wide. Oops. Okay, so now we've listed out all the weights. They're in order, so I just start moving to the middle. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm not in the middle yet. Move again. Move again. Here we go. 37 is the one in the middle. So that's the median of the numbers. Does 37 look like a better answer for what's representative of this classroom? It's a lot better than the 30.5 over here. So how does this process fix our problem?
David, I'm not sure why you added the one, and the 2.
Oh, from the 3 stuffed animals.
From the 3 stuffed animals. Okay, got it. Thank you.
Now, when we are doing the median, whatever the problem is going to be, it's going to ask us to find the median, or how are we going to know that the median?
It has to tell you.
Okay, okay.
But how did this fix the problem? How come we got a number that looked like a nicer answer? Now let me put it in a different color. So this was the median, and this was the mean. How come the median turned out nicer? It turned out more typical, more representative, more most common.
Is it because it's including all of the numbers, including the stuffed animals, which when doing the mean, it broke it into two different types, but now it's including them all.
Actually, it's the opposite.
Okay.
Let's imagine that we put one of the teachers in, and this was 141 pounds. It doesn't change the median at all. It's just someone we skip over. So what happens with the median is anything that's not representative of the group gets skipped over, and it barely changes our answer. It doesn't matter whether this number is 41 or 141 or 1,041. It's just something we're going to skip over. So what are some realistic situations where people would want to use the median instead of the mean?
It seems like if you were thinking about age, it might be better to use the median. Because then if you're doing a group of people and you've got, ages 2 to ages 60, and you're looking to find kind of the happy medium, if you take the average and you have the mean, then it might skew your numbers. Where with taking the median, you're going to find more of that middle age.
Right. And it depends some on your demographics. If you're wondering what's the typical age of someone attending the Oregon Country Fair, then the kids and the grandparents are probably not very many of the people there. Skipping over them would make sense. If you're
what about, sorry. What about in like sales? Like if you were running a grocery store or something and you wanted to like figure out like how much on average you're making off of a certain item, does that work?
Mm-hmm. There might be a freak day where everyone decides, actually I had one happen just before Christmas. It was hard to buy crickets if you have a lizard. Everyone was hoarding up on crickets thinking there wouldn't be deliveries around Christmas and New Year's. So you wouldn't want to count those days in your cricket sale patterns. So let's skip over those days where crickets got too much demand for no real reason. Common examples also include home prices. If we all live in a neighborhood and Eli has this elaborate mansion and the rest of us don't, then to some extent it helps our average home price of the neighborhood that he's one of our neighbors. People might want to stop by and see his fancy yard. But you can't really say that my house is worth more just because Eli, the mansion owner, lives next to me or near me. So neighborhood home prices are often the median. We'll take both the extraordinarily expensive house in the neighborhood and the rental that's been destroyed by college students for 30 years. And we won't count those. We'll skip over those and pick the middle ones as we list them. Incomes also happen. If we want to say what's the typical income at a company, then this group likes Target, right? So what's the typical income at somebody who works at Target in Eugene or Springfield? Then the person that works part-time for 2 hours a week, we probably shouldn't count that person. Right? Who knows why they're there? It's just some job to get on their resume. And the person that owns the store, we might want to know what their income is for other reasons, but that's not typical, right? That's the owner of the store. So we'll skip over the very high and very low and just count towards the middle and pick who's in the middle. So those are all examples of medians. Okay, the last one is mode. Here it is. The mode is which thing happens most often. If it's a tie, all the ties are modes. If no number is more frequent than any other, then there is no mode. So it's who wins the election. who gets the most votes, that kind of thing. And you will never hear mode in a math class usually, because just who gets the most counts, who gets the most votes, whatever, that's not really a math problem. That's just counting. So mean and median and mode are always taught together for traditional reasons, but the ones we care about are the mean and the median. The mode is just there because I'm supposed to tell you. Okay, so you've learned about histograms. You've learned about ways to talk about average or typical or representative or most common. You've learned some of the things to be wary of. Questions so far with what we've done? No. Okay, well then I'm going to do something I haven't before, but should. So I'm going to go down to our week 4 and actually click on the textbook chapter. I've mentioned before that I shouldn't just teach by looking at the textbook and going through everything. My job is to give you a different point of view so that the textbook is another thing that helps you learn and not just more of the same. But I also think some people haven't looked at the textbook enough. So maybe if I spend some class time in it, then it will encourage you in your not class time to also be looking at it. So this is the describing data chapter, and it's going to talk about some of the same things we just did and some slightly different things. The first jargon it talks about is the frequency table. So it has 2 columns. One is the category, like what color things are in example 1, and the other is how many times that happens. How would I turn a frequency table into a histogram?
Are you wanting one of us to answer that question?
Yeah.
So I think, I'm not sure, but I think to make the histogram, wouldn't you just make a line? You have to have 2. So let's say that the horizontal one would be the colors, the
Okay.
category, and then the horizontal one would be the numbers. And I think from looking at it, you would do 23 to 52 so that each one has its own one, that each bin, I guess is what you would call it.
Right. The colors would become the bins.
Okay.
And now we get to decide how evil and deceptive Ashley is. So she recommended starting at 23, which we certainly could do. And the highest would be 52. So if we drew it that way, and I'm going to take a picture of this slide right now for our next thing. Then what would we have? Gray goes right up to 23. Black is 39. What's halfway between 23 and 52? That's going to be about 38. That's going to be about 30. It's going to be about 45. So blue is a little bit higher than 23. Green is the tallest one. Pardon my artwork, that's not what I'm being paid to do. Red was about 41. White 36. And black 39, something like that. Except for the quality of my artwork. Is everyone happy?
Yep.
That's good.
Where'd you get those numbers on the histogram? Where'd you get the 30 and the 38, or how'd you come up with that?
I first said, what's 52 minus 23? And then I divided that by 2 to see it was about 15 to go from 23 halfway to 52.
Okay.
So I'm just trying to cut it up in even pieces.
Mm-hmm.
So this makes it look like all of the numbers are fairly similar. We could also say, let's not start with 23, let's start with 0. So then that would be 26. Halfway to 26 is 13. Make that look more like half. Yeah. Another 13 would be 39. Right? I'm saying this one makes it look like more there's a difference. Right? This one is a lot smaller than that one. If I start at 0, then the 25 goes here. The 52 is still the tallest. The 41 is like that, more or less. White is 36. Black is 39. And gray is 23. So now they look more similar because we're starting at 0 rather than kind of cutting off how much they were all similar down below. So how you label your frequency axis changes things, as well as what things you put into which bin if you were doing test scores. Do you want to stretch these out or not? We could even have a stupid version where instead of measuring from 23 to 52, we could start at 0 and go up to 1,000,000. And then all of our bars would just be little squishes at the bottom, right? None of them get high at all compared to the 1,000,000. So be careful of this in real life. People will want to exaggerate things. When you see a chart, when you always ask, is it starting at 0? And if not, why not?
I have a question on that, the one we just did with the 0 to the 1,000,000. I get that they would look a lot smaller, but wouldn't they still be over the 0 considering
yeah,
the numbers are there?
I should make it so that 0 is down here. Right, not up a little. You are right. Thank you, good correction. Okay, back to the book. So that's a frequency table. It's almost a histogram on its side, right? If I took this thing, no, I took There we go, this thing, and turned it like that. It's almost like it's a histogram, right? How far up things go.
And I do have a question about between my graph and your graph, or the way that I said to do it and the way that you said it. Is either one of those right or wrong, or is it just kind of how we decide that we want to make the graph?
They are both valid graphs. They have an exaggeration in one way or the other. Right? This person is trying to say, look, yeah, one is big, but we're all pretty close to each other. I'm sorry, this one is saying, wow, this guy has like way more income than this one. This isn't fair. We should go on strike. And this one is saying, yeah, some are bigger than others, but we all have a lot. So their emphasis is different, but the math is all valid, except that, again, I should put 0 down at the very bottom and not off the bottom. Okay. So a bar graph has a bar for each category. We just did that already. Theirs, of course, looks nicer than mine. How would I make a nice one like this rather than my kind of ugly handwritten thing?
You could use software, you could use Excel, or I believe you wanted us to use paper or to grab paper and rulers and markers and stuff. So if we had a ruler, we could just make straighter lines.
You could also use graph paper.
Yeah, graph paper.
Okay, is there anyone that wants to see me make this quick in Google Sheets?
Sure.
Okay, so I will go to the drive that I've already with all of you. And I have made something here. Okay, so here is a Google spreadsheet. And I'm going to say that this is.
A spreadsheet is a computer application for organization,
No,
analysis, and storage of data in tabular form.
Sorry, my phone thought I was asking a question. Okay, let's name this Math 105, describing data. And I'm going to take this and rename it just as making a histogram. Does everyone know that at the bottom you can have different pages in a spreadsheet? So we'll get to that later. No. Okay, our thing was, can I be fancy and paste something in a Google Sheet? I don't know if I've ever tried. Oh, wahaha, look at that. Okay, so I'm just going to type it blue, green, red, oops, white, black, gray. So if I want to make a histogram of this, I highlight it. I go to this little button here that says Insert Chart. And it's going to say, is that what you want? And I'm going to say, no, I want a bar chart. And then I can tell it some other things. Customize, axis, title. First histogram. The vertical axis. Yeah, that's good enough. Something like that. So ta-da, I've made it. It took only a moment. So highlight everything and push the little button up.
Which button? You
That
push. Oh, okay. Thank you.
Okay, moving on. The textbook comments that you could put lots of numbers on the side or few. You can have lines going across or not. If you don't have lots of lines going across, it's polite to put titles on each bar so people can read it more easily. Then they give us a new definition, a Pareto chart. So a Pareto chart is a bar graph that's in a certain order. We have to take the things that are happening most and put them first. So our histogram isn't a Pareto chart. What could we do? I'm going to insert a row above and move that one down. Nope, still not fixing it. That one needs to be like way over here. Insert row above. Ta-da. Oh, still not a Pareto chart. You need to get rid of blue twice. White needs to scoot over a little. Insert row above. Delete that row. Delete that row. Okay, now we have a Pareto chart that's sorted from tallest to shortest. Any ideas why you'd want to do that?
To show whichever one is like the most common or the most popular, or like the highest.
Or to show ranking, to show the relative rank between them.
Mm-hmm. Maybe you're wondering who
said-
got like first, second, or third place in a contest, or which Olympic contestant got the most gold medals, first, second, and third, or something like that. There's also this idea named after Pareto. Have you ever heard of the Pareto principle, which is sometimes called the 80-20 rule? No, so the Pareto principle says that 80% of what happens in a situation will often come from the most important 20% of the things. Or so if you look at just the things that are the most important, you can often skip the rest. Something like that. I might be getting that wrong. So anyway, he rearranges his also. In another example, they have environmental issues and how many people vote for those. And then they make a pie chart. We made one accidentally when in our spreadsheet, I highlight these things and I said, give me a chart. Its first instinct was to give me a pie chart for some reason. This is so fancy. It even labels the wedges and puts what percent they are on each. How would I make a pie chart if I don't have a computer?
You mean literally just drawing one out?
Yeah, they're kind of tricky.
Protractor?
Yeah, so the official way is that if I was to start at the top of the circle and go around, then how many degrees are in the whole circle? Okay, I'm going to move this off the screen just as I search Google for protractor round, see if I can get a good picture to paste. That's what I want. Okay, so here's a picture of a protractor. Often they're just made physically as a piece of plastic that's only half a circle. But if I do make one that's a whole circle and go all the way around, then all the way around would be right here. Make it bigger, 360 degrees. Does that ring a bell? So what I could do is take each of these and multiply them. If I have 10.6%, I could say that that is 0.106 times 360 degrees would be whatever that is, 38.16. So I would take my protractor, move it physically on the paper, go from 0 to 38.6, and that's how big the wedge for this one would be. But that's annoying. No one wants to do that. So I'm going to show you a better thing. So take the, let's take my ugly one. Yeah. Draw something like this on your piece of paper. It can be just as sloppy as mine if you want. Let's make our own little bar charts for this data. So I'm going to take my clipboard and colored pencils that I warned you you might need today. Don't take too long. No one's grading your artwork. I just want to show you how the process works. Everyone have something hand drawn? I just took a photo of mine. If I can take a photo, then you must be done pretty soon. So if you have a nice bar chart, hold it up. Okay, now we get to destroy it. So take your scissors that I said you should have today and cut out the bars. I'm going to mute myself so you don't have to hear my cutting. Okay, has everyone cut out your bars?
Yes.
Your next step is to take your bars and tape them end to end like you're making a train or a caterpillar or whatever you want to call it. Make one long train out of your bars. The next step is tricky. You have a train of things. See what I'm holding up, a long bunch of bars taped together. Make a ring out of it. Take the first one and last one and tape them together so you have a ring. My wife says, "You're making bracelets." Let me know when your ring, your bracelet is done, then I will go on because it gets a little tricky. Okay, people are saying done in chat. If you're slow, that's okay. Take your ring and draw on your paper. You'll need probably another piece of paper because you just destroyed the first one. A circle with a dot in the middle. And you're going to take your bracelet and lay it as round and centered as possible around the dot. And it doesn't matter how big your bracelet is compared to the other circle. It could be bigger or smaller. So I'm going to pretend that my bracelet is bigger than the circle I draw and say that the first bar that's blue was like this portion of it as I'm drawing on the screen. My green bar was a longer bar. My red bar was not quite as long as green, but almost. My white bar was that one. My black bar was there. And then my gray bar is there. So you have something in front of you that is a physical bracelet around or inside a circle with a dot that you've drawn, right? Now, wherever the bracelet changes colors, that's where your spokes of the wheel go for the pie graph. Then you can take your bracelet away and just shade in the wedges with the right color. Ta-da! So without any measuring, without all of that annoying things of we have to multiply 360 degrees by all these different percentages, you've now made a pie graph. And yes, yours is not as perfect or exact as what the computer would draw or measuring with a protractor a bunch of times, but this was a lot more fun and no one at your science fair presentation will ever care. So 2 reasons we're actually having you do this in class time. One is that maybe you have kids at home and this would be good for teaching them about bar charts and pie charts. The other thing is that I want you to see how the size of the wedge fits the size of the bars. We don't really have bars lying around the edge of a pie chart normally, but you can kind of see how they correspond to each other.
That was awesome. I'm a really visual learner. So that I really appreciated all the tactile and the pictures.
It would be a lot more normally, but I can't give you all my pattern blocks and things, right? I have buckets of toys, but you just don't know that. Okay, I want to do just a tiny bit more here, and then let's look at your homework before I say goodbye for the week. So, different kinds of pie charts. When you have a pie chart, you want the numbers to add up to 100%. So, there's some warnings in this textbook about bad charts. 3D charts that are hard to read, picture charts that hide the data, comparison of the same data in 2 different ways. This one starts at 0, the other one starts at 40. We talked about some of these already. Here was a poll. 4 people asked, do you agree with the candidate about different things? And 42% agreed with Nguyen, 35% agreed with McKee, and so on. And these numbers could be bigger or smaller than each other, but they don't add up to 100 because people can agree with all 4 candidates. So this is a very weird pie chart because things don't add up to 100. Not all information looks nice, is appropriate for a pie chart. And that's as far as we're getting. We'll do more about this next time I see you. Okay, back to your homework. The activity for this week, before you dive into the homework, you should always look at the activity. So here's a table. It's going to ask you, just like we did, to make bar charts, make decimals. This goes right back to this one, right? Find the decimal amount for each section. You'll need to do part divided by whole. Whoops, where are we? We're not there. Then you multiply it by 360 to find how many degrees. And if you happen to have a protractor at home, you could do that. Otherwise, do what we just did. Take your second copy and cut it apart and put it around the circle and make one of these. So good review to solidify what we did today. Your homework is different. Part A, Part B. Part A has 2 surveys. What type of animal makes the best pet? And what's your favorite movie genre? And then we ask you different questions about that. I didn't actually go into the difference between this. What we are doing so far is categorical data because everything fits in categories. It's called quantitative if all of the numbers at the bottom are numbers also, like test scores. But we're saying it doesn't have to be. We could have months, we could have colors and so on. So anyway, questions about those. And then your short answer question for part A is, for these cute pictorial datas, make the actual Pareto chart and pie chart. So shouldn't take too long. No one will grade you on your artwork. You don't even need to turn on a computer about that if you want to do things by hand. Part B is different. If you don't get part B done before Monday's class, that's fine, but you can. There's nothing else you need to learn. We can talk about this more next week if we need to. But here is a histogram of a household's electrical use, and it asks you questions about that. If you want to see the numbers, click that Show Data Table, and the numbers show up, but you don't need the numbers. So it asks you more questions about a histogram. So starting with the chart, as opposed to 4A, where you started just with the data and you made the chart, right? So now you're working the other direction. And the theme of this is about people's carbon footprint. And that ties into your quiz, the short answer question, where you are going to take too much information, pick a way to argue something persuasively, pick in your mind who your target audience is, and then try and present something persuasive. And if you want to be a ham on the stage Monday in class or study session, you can present it to everyone, or I suppose Saturday night too. Or if you want to just turn something into me and not show off, that's okay. You can be shy.
I have a question on part A's homework on number 5.
What's the question?
So on number 5, it wants to know if you were to create a bar chart, which of the following would be the best choice for the range? And I've counted, so I know what they are, but would I go to the highest number that I have in my category, or would I go above that so that there is a number above the biggest bar?
Yeah, it could be either. It doesn't really matter if your bar is at the top. And not all of these homeworks have only one right answer.
Okay.
Let me peek at that one just to make sure that I'm not. That's number 5. Yeah. If you make it too much space at the top, then that would be awkward. Remember this one where it went up to 1 million? So that's obviously exaggerating, but too much space at the top forces the bars to look squished and more similar than you might want them to be. So a little bit of space is fine, but probably not too much. And that's the clue I will give you for that one.
Okay.
So you would be fine with like a Google Documents page for that assignment? With
yes, you saw how quick it was.
Yep.
You just take things, type them out, highlight them, hit the button, ta-da, I'm done. That is great.
Yep. So I want to say something really quick before class ends. We're trying to get a study group going, and we're going to try and meet tonight around 8. And I'm going to throw a Google link up in the comment section if people want to click on that link at 8 and join us for a study group. I think we're going to work on either the activity or the homework tonight. So.
Okay.
Thank you.
What is the Google link? Oh, a Zoom thing. Okay. Anything else before we're done? No? Okay, I have made a copy of our Jamboard. If someone wants to be the destructive person that goes through and hits clear frame or scribbles all over it or something, you can now totally mess up our official math lecture Jamboard because I have the archived copy for links. Have a good day, everyone. Maybe see you at the Saturday study session.
Thank you. Take care.
Oh, David, I have a couple questions about the midterm. Should I just save those for the study group, or just now is now an okay time?
Probably save them. I should check in and get my kids adjusted to their fourth.
Okay, I'll talk to you about it Saturday then.
Okay. Maybe someone here wants to hang out with Eli.
I mean, Saturday works.
Saturday
we're gonna meet later, so.
Okay.
Okay, thank you.